If we pick up where we left off on yesterday, and we had this idea of we had these three lines, right? This kind of idea that this is the speed line, and this was the distance line, and this is the time line, right? So we had this idea that we had this, they went speed 95 kilometers per hour, and they went a distance 130 kilometers during that time. Can we find the time it took to do that? Can we find the time it took to do that based on this information? The answer is yes, because speed equals distance divided by time. So if I rearrange that, I can find time equals distance divided by the speed, just by doing that. So if we actually take a look at the distance, 130, and divide it by 95, we get 1.37 hours. 1.37 hours. Now the problem that we have at this point is the hours that were given to us before were in hours and minutes. So you can do it two ways. You can convert back here, take this back to hours and minutes, or you can take the 3 hours and 20 minutes into a decimal, which is what I would recommend. I'd probably work as a decimal initially. You find out that's 20 out of 60 is 0.3, so 0.3 repeating hours. Okay? So if I know that this part of the trip was 1.37 hours, I know the total trip is 3.3 repeating hours, I can just subtract those and find out how long it took for the second part of the trip. And so you get 1.96, right? 1.965 actually hours. 1.965 hours. Now, if we know that we're going 65 kilometers per hour, I can find the distance now. Remember, speed is distance over time, and I can say distance is speed times time. So I can take that 65 and I can find out 127.7 kilometers, or 128 if you round it. So now I've actually solved all the puzzle. Yes, ma'am?
Sorry, which one on the second kind of column, which one did you find first?
Okay.
Completely empty.
Yeah, okay, let me go through it. I'm gonna put some numbers next to this. So these two, right, are going to solve that. Good? Then these two, all of this right here, which is number 2, solves for that. Good so far? Then I take these two, number 3, and solve for this. Okay? So once I find the time, I subtract from the total, get my hours. Then I take the speed and the time to get that. And really what you're doing is, this one is number 1 and this one is number 3. Number 2 just required a subtraction, right? Number 2 was just a subtraction. So 1 used time equals distance divided by speed. And this one was distance is speed times time to get that answer. Yes, ma'am?
So you found 3.3 now is the total, and then you subtracted 1.7 from it?
Exactly. Exactly. So this minus that gives me that value. Okay? So let's take a look at the problem again and see what they're asking. How far is your hometown from school? All right, so A, how far? So we're just going to add this up. I'm going to add it up and make it 258. I'm going to just round that to 8. All right, that would be reasonable. So 258 kilometers. Everybody good with that? B. It says, and what is the average speed? Okay, now we have 95 and 65. The temptation is to go and take 95 plus 65 divided by 2. The problem is they traveled for different lengths of time. Because they're traveling at different lengths of time, the average speed can't be done that way. The average speed is total distance divided by total time. All right? So if we're doing that, we're going to take that 258. We're going to divide it by 3.33333 hours. And we're going to get 77.4 kilometers per hour. See, if you just average the 95 and the 65, you get 80. Well, that makes sense if it was halfway. And since it's not halfway, and the time was different, it ends up to be slightly different. So he spent more time doing 65 than he did doing 95, therefore it's less than half. Okay? Due to the rainstorm. Okay? Questions on that before we go on? Again, remember, average speed is total distance divided by total time. Right? Questions before we go? All right? Normally I'd use the whole board, but I can't with the video. So it's your fault at home that I'm having to do it this way. I hope you're watching because it's fun. All right, number 9 says a person jogs 8 complete laps. Do you want to say something to your friend?
Yes. Oh my word. We miss y'all.
David doesn't.
I just said hey.
Oh, you did say hey?
We miss y'all.
Hey.
Oh my China.
Anything to waste time on a Friday. All right, here we go. See if I can get this straightened back up. Okay, what we have, person jogs 8 complete laps around a quarter-mile track, a total time of 12 minutes. Calculate the average speed. Now remember, average speed is total distance. So 8 laps around a quarter-mile track. How many miles is that? 2 miles. So your distance is 8 times 0.25 miles is 2 miles. Now, I used to run on a quarter-mile track. By the way, not very fast, considering the athletes that I have are a heck of a lot faster than I ever was. Except hurdling. Hurdling, I was okay. But the athletes we have here at Westminster are so much better. Even the girls. I'm like, girls are faster than I ever was around the track. It's crazy how fast they are. Distance is 2 miles. We had a quarter-mile track, not a 400-meter track when I was growing up. All right, so what we have is 2 miles, and then the time is 12.5 minutes. Now, what do you want to do about that? Do you want to go miles per minute? Or do you want to do miles per hour? Both are correct. If we did this, I would say the speed 2 over 12.5, and this is miles in minutes. You can do that. Right? How would I do the speed as 2 miles in how many hours? How would we do that? How do we convert minutes to hours? Divided by 6, beautiful. 12.5 divided by 60, and it's 0.208, and then there's a 3 repeating. And so we take the 2 and do that, and we get 9.6 miles per hour. And then if we do the 2 divided by 12.5, we get 0.16 miles per minute. Both are the same. It's just the units that you want to use. So you go 16 hundredths of a mile in every minute. So, questions on that? Now, if you're a track runner, that 12.5, that's 750 seconds divided by 8 laps. So you're about 93 seconds, 94 seconds a lap for if you've run. I know Mackenzie's run and you two have run. 94-second lap doesn't sound like much. You're going, wow, that's like jogging. Yeah, it is. That's a 12:32 mile. A 12 flat 2 mile is 90 seconds. Right? That's where Hallie and Hannah and Maddie and all those would run. That's what they would do. Okay? Do you have a question?
What's after 96?
Sorry, miles per hour. That's miles per hour. MPH is miles per hour. That doesn't mean meters per hour. MPH doesn't mean meters per hour. It's miles per hour. That's just the unit that we use. All right. Any questions on that? All right. The next one is, I think, a difficult one. It's a number 2. It's only difficult if you don't see how this works. You remember how I drew the lines before? We're going to do that again. So we're going to take this idea of these 2 trains. All right, so you have this train over here, and you have this train over here. And the first time I did this problem, I had them on the same track. Probably not a good idea because it causes a wreck. They approach each other on parallel tracks, right? So they're going to pass each other. So what information do we have that I can draw on the board? I've got 2 trains on parallel tracks headed toward each other. What piece of information do I have that I can put on the board? You have to actually read the problem to figure it out.
8.5 kilometers away from each other.
All right, so I have a distance of 8.5 kilometers from here to here. Excellent.
They're both going 95 miles per hour, I think.
Are they?
I mean, kilometers per hour.
95 kilometers per hour? All right, so 95 kilometers per hour and 95 kilometers per hour. Okay? So, what's the question?
When will they pass?
How long will it take for them to pass each other? Okay. So what's your gut feeling?
Like how long is it?
How to solve this? What's your gut feeling on how to solve it?
They're going the same speed and they're the same distance apart, even half the distance.
See what he did? It's going the same speed. They're going to cover half of the distance because they're going the same speed. Critical that you understand that if they're the same speed, they're going to cover the same distance in the same length of time. So you can cut this in half, and now you have a distance of 4.25 kilometers. Speed is distance divided by time. So time is distance divided by speed. So at 95 kilometers per hour, you're going to take 4.25 and divide it by 95 kilometers per hour. And this is how many hours it's going to be, right? Time is in hours here. And so time is 0.0447. Yeah, 0.447 hours. Now, I don't know if that number confuses you. It's not my favorite way to look at time. It's 0.0447 hours. So what would you want to do?
Seconds or minutes?
Let's go to minutes first. 2.68 minutes. A little bit easier. All right, 2.68 minutes. And then if I wanted to, the 0.68, 2 minutes and 41 seconds. 2 minutes and 41 seconds is essentially what it will take for that to happen. Okay, we good with that? Pretty straightforward. The key here is knowing that because they're going the same speed, the distance is half. Now, I'm going to throw a wrench into the works. It's kind of what I do. Okay, it's kind of what I do. So we're okay with that, because if we start there, then the next problem, we're changing one thing. $85. Based on what we said about the last problem, what can you tell me that's not true? Yes, ma'am.
You're not gonna go the same distance and same amount of time.
They can't go the same distance, same length of time because they're going at different speed. So, are they going to meet in the middle? Where are they going to meet? Which side of middle? Very good. So, if middle is here, then they're going to meet somewhere on that side because, now that may be exaggerated, right? But they're going to meet somewhere on that side because in the same length of time, they're going to do this. Okay? So the time here, the time is going to be equal to this time. They're both the same time, but they're going to be different distances. So we've got to figure out how to do this. Now there's two ways to do it. I have a method that I like. Some people don't, so let me give it to you. I do what's called closing speed. For example, if this guy was sitting still, how fast would this guy have to be going to cover the 8.5 kilometers in the same length of time as both of them moving? If this guy was sitting still,
Fast would you have to go?
how fast would he have to go?
Like, so I'm changing the speed of the.
So if I set this guy to 0 kilometers per hour, how fast would this guy have to go that way to cover the whole distance in the same length of time as this guy goes to here and this guy goes to here?
So you take 8.5 divided by the 85. Should we know that?
I'm going to change his speed. Okay, I'm not saying, okay, you're answering a different question. I'm not asking how long is it going to take him to travel the 8.5 kilometers. I'm going to say the time it takes for these guys to meet here, if this guy was traveling, he'd only get to here, right? So he has to go faster to get all the way to here because this train's just sitting still. So he has to go faster. How much faster? Okay, I can't hear you with my mask and your hand on your mouth.
Over 2 times as fast
Over 2 times as fast. Why did you say that?
because it's less than 95 is the original speed of light is 95.
Yeah, your thought process is beautiful. Okay? Because if he went twice as fast, he wouldn't quite be. See that 95? It's a little bit more than twice, which is exactly what you said. Here's what I call this. I call this closing speed.
Add the speed together?
Add the speeds together. So he would have to go 180 kilometers per hour to cover this 8.5 kilometers in the same length of time as this 85 would get to here and this 95 would get to here. Because that guy's sitting still. So you have closing speed. So just think about it. If David was over there and I'm here, if I start walking to David, it's going to take a certain length of time, right? if as I'm walking, David starts walking to me, it's going to take less time. Because now you have the speeds are covering the distance from both ends. They're covering this distance in less time than if they were sitting still. So if this guy sits still, I got to be traveling a heck of a lot faster. So it's called closing speed. So two objects that are closing on each other, you add their speeds, and that'll tell you the time that they meet.
And then you do from there, you calculate the time that it happened.
To cover the 8.5 kilometers. Remember, closing speed, I add them, and so my closing distance is 8.5 kilometers because I cover the entire distance. Because what I'm doing is I'm taking both trains and putting them into one speed. So what distance was covered by both trains? So now I have 8.5 kilometers divided by 180 kilometers per hour. That tells me how long it's going to take for them to meet right here. So that turns out to be 8.5 divided by 180. 0.0472 hours, or 2.83 minutes and 2 minutes and 50 seconds. Now, what was the answer to the original problem? What was the original answer? 2 minutes and what? 41 seconds. So by slowing down slightly, it increases the time for them to meet. Now, what distance did the 85 cover? Well, the 85 covered to here. It took him 2.83. So you take your 85 and divide it by your, what do you mean? Time is, yeah, your distance divided by speed. So your distance is speed times time. And that's going to be your distance. So your speed's 85. Your time is 2.83 repeating. And that's your distance. Okay? So that'll tell you how far from here. If you did 95 times this time, it would give you a greater distance, but that makes sense. It travels greater distance to get to this point. Now, can you do this, for example, if I start running and David's chasing me, can I do closing speed? Yeah, but I have to subtract. Because if we're running the exact same speed, he'll never catch me. If I'm running faster than him, everybody laugh all at the same time. If I run faster than him, he'll never catch me. If I run slower than him, he can start, as I'm moving here, he can start closing the gap, but he closes the gap based on the difference. So closing speed, when you're coming toward each other, we add. When we're going the same direction, we subtract. And then now you know what speed we're doing, and speed, distance, and time fall right into place. Okay? Okay, let's take a look at number 13. Airplane travels 3,100 kilometers in a particular length of time. All right, you have 3,100 kilometers at a speed of 790. Encounters a tailwind, boosts at 990 for the next 2,800 kilometers. What's the total time for the trip? Okay? Pretty straightforward. You solve, you take the kilometers, divided by the speed, you get the time. And then you take the 2,800 and divide it by 990, you get the time. Add them up, you get the total time. The average speed would be your 3,100 plus your 2,800 divided by the time it took. Okay? Now, Number 15, I am going to wait until we are together as a whole class, because number 15 is a classic problem that will show up about 3 different times in different forms. So if we do it on video, it's not going to work as well. Everybody being here asking questions, what's going on with this? Because you got a bowling ball, speed of the bowling ball, distance of the bowling ball traveled, hits the pin, the sound comes back, and it's a number 3. It's the first number 3 that we will ever do. So we're going to do it together, right, on Monday. We'll come back, we'll do number 3, and then we'll start talking about acceleration, and then we'll have a couple of labs next week. And then the quiz next Thursday is going to be on just the problems that we've covered, okay, in this chapter. So 1, 5, 7, 9, 13, 11, and 13. Those are the only types of problems that will be on the, those are the only ones that will be on the quiz on Thursday. A problem like number 3, the number 3 problem like number 15, those appear on the test only when I'm comfortable that you know how to solve them. Okay? So numbers 1s and 2s are going to be the majority of your test. There might be a number 3, but only after we've gone through several in class. Okay? We good? All right. Have a great weekend.